In today's note, we're going to be looking at present value. So present value is basically when we know what the future amount the amount of money that we want to have in the future. When we know that amount, but we want to know how much do we need to start with, which is sometimes the case when we're saving money, we're going to be using this formula. So again, it's like saying, I know that I need to have $10,000 saved up to purchase a car. In 3 years, how much money do I need to start investing now, or how much money do I need to start with now, so that after interest I have the $10,000. So this formula is basically just a rearrangement of the compound interest formula that we just looked at in the last note. So you will see very similar things, it's just rearranged. So the present value formula is P equals A divided by 1 plus I to the power of n. So again, same things, it's just rearranged. A is the total value of the investment, or the future value, so how much money we want to have. P is the principal or present value of the investment, so how much money do we need to have now. And I is our interest rate, again as a decimal per compounding period. So again, remember this was when we did the percent divided by the compound number. So you will need to again remember those compound numbers from before. So again, what does annually mean? What does monthly mean? And so on. And n is the total number of compounding periods, which was just years times compound number. So again, the exact same things that we would need for compound interest, just in a rearranged formula. So again, the first thing we're going to look through an example. So calculate the amount needed to be invested today. And I'm going to highlight this because this is important. This is what you're going to be looking for, right? Any question where you're trying to find out how much do I need to invest today? How much do I need to invest now? That's going to key you into what formula you have to use, right? Anything that refers to how much do you need to have in the present, you're going to use this formula. So how much, or calculate the amount needed to be invested today in order to have $5,000 in 4 years if the investment is compounded monthly at 3%. So again, some key information. Again, we've already talked about investing today. So how much do we need to have today in order to have $5,000 in 4 years compounded monthly at 3%? So those are our key things. So what does that mean? What does that tell us? Our A value, we know the future amount is 5,000. So that's how much we want to have. Our P, or our present value, we don't know. That's what we're trying to figure out. Our I is 3% divided by monthly, so divided by 12. So 0.03 divided by 12 is equal to 0.0025. And our n value is the number of years, so 4 years times our compound number, which is monthly. So once a month for 4 years, we get 48. So we have all of our numbers. So now we need to just plug it into our present value formula, which is P equals A over 1 plus I to the power of n. P is equal to 5,000 divided by 1 plus 0.0025, which is to the power of 48. So with this formula, this one's going to be a little bit more complicated to do all at once. So I would recommend doing or simplifying the bottom part first. So 1 plus 0.0025 to the power of 48. You get 1.127, and then divide. And you get $4,436.56. So that means, therefore, $4,436.56 needs to be invested today. So it seems like we need to have a lot, but again, remember, interest is basically free money, right? You're not doing anything to earn that money other than just saving your money. So if you think of it that way, it seems like a lot to do nothing. So how much interest would the investment earn? So this is where we need to go back to our A equals P plus I formula, right? We know how much we have, or we know how much our future amount is. 1,000, we know how much we have, or how much we should start with. I want to figure out what my interest is. So basically it just works out to your future amount minus your present amount equals the interest. So 5,000 minus 4,436 and 56 cents, and we get $563.44 is equal to our I value. So therefore the investment earns $563.44 in the 4 years, compounded monthly at 3%. So, and that's how you use the present value formula. So there's 4 practice questions. I'll go through the first one and leave you with 3 to do on your own. So in 1, we want to calculate the present value of an investment that earns 2.2% compounded quarterly if in 5 years the investment is worth $1,500. So again, we're looking for the present value. This one kind of basically tells us that. We know how much it earns at the rate. We know the compound number, how many years, and what the future amount is. So again, going back and filling that out, our A value is the 1,500. Our P value, we don't know. Our I value is the percent as a decimal, so 0.0225 divided by the compound number, which is 4, because it's compounded quarterly. So then 0.0225 divided by 4, get 0.005625. And our N value is 5 years times quarterly, so 4, which is 20. So that means it's 4 times a year for 5 years, which means 20 times in total. I'm going to use my formula. A equals, not that one, sorry, I was thinking of the compound interest formula. So the present value, P equals A divided by 1 plus I to the power of N. A is 1,500 divided by 1 plus 0.005625 to the power of 20. I'm going to simplify the bottom first. Again, you can probably do both at the same time if you're comfortable using your calculator. If you're not, or you seem to be getting something wrong, I would say in this case, simplify the bottom first and then do your division. So 1.1187 is what that bottom simplifies to, and then this works out to $1,340.81. So therefore, the present value is $1,340.81. So we're using the same numbers and the same ideas as compound interest. We're just using a rearranged formula because now in this case we're looking for the present value and not the future value. So again, there's three other examples to work through, so try working through those to practice this.